Any questions at all about the homework last night? Oh, you didn't have homework last night. I forgot. Um,
Oh, what to say?
I know. Yeah, I was already thinking ahead. Get out your paper and pencil. Let's go ahead and do this. So today should be an easy day. The next couple of days, it's going to get a little bit harder, but it is all building on the background of solving 2x2 systems. So the objective, I always write the objective up here. I forgot to write it today. But your objective, let me adjust that just a little bit. Your objective is going to be solving, students will be able to solve any 2x2 system. Now that's it. All right, 2x2 means you have two equations, two variables, because guess what we're going on to tomorrow? No guesses? We're going on to 3x3 systems, which means you've got three equations, three variables. Gets so fun, totally fun. So all we're going to do today, some of you guys need to see this. Some of you do not. Here's your hints. You've got basically 5 steps. You will rarely have to do the first one. Line up your variables and your constants, and then solve. So I want you guys to do this with me. We've got about 5 or 6 problems to do together. You have homework tonight. You have to know everything about this stuff. Because if you cannot do this, you cannot do the Algebra 2 part, which we're doing tomorrow. So some of you guys might want to write those tips down, because once we go on to this tomorrow, you've been doing this again since pre-algebra, so we're going to work under the assumption that you know how to do this. So a system of equations, really what it is, you've got two equations that are happening on the same graph or at the same time. So typically, we're trying to find out where they intersect. So the solution of this, which you don't have to write this down, but the solution is where these two lines intersect. We could solve it by graphing, but that'll take a long time. We can solve this by substitution, which is useful sometimes. But the way that you're going to have to do it most of the time is by eliminating a variable. Now notice how I said that we are trying to eliminate a variable. How you do that is get a set of opposite coefficients. So opposite coefficients, right now my coefficients for x are 1 and 3, those are not opposites. My coefficients for y are positive 2 and negative 2, those are opposites. Once you have opposite coefficients, you add the two equations together. So when I add these together, make sure they're lined up. 1x plus 3x is 4x. Sorry. Positive 2y plus negative 2y, these essentially, they're going to cancel each other out. That's why you want opposites, because they cancel each other out. We're eliminating a variable. Equals, and 5 plus negative 1 is 4. So we're going right through all of these. So we lined up our variables. It was already set up. Get a set of opposite coefficients. We already had that. Add the two equations and solve for the remaining variable. So if I divide both sides by 4, I know that x is 1. Once I have found the value of one variable, I can plug it into either one of the original equations, whichever one you think is easiest. So I think the top is easiest. So if x is 1, I literally plug 1 in right here. So I have 1 plus 2y equals 5. And then I solve for the last variable. Divide by 2, and y is 2. Your last step is to make sure, and I forgot to write this up here, make sure that you write them as an ordered pair. So alphabetical order, always. So your x is 1, your y is 2. And all that solution is saying is that's where those two lines intersect at the point 1, 2. Now that one was a pretty easy example. Any questions? So almost too easy, I'm assuming. The next one is almost just as easy, almost. Now, on the next one, the very first thing that I want you to see, people will just glance at this and they will assume that it's already lined up. These are backwards, so you might have to rewrite your equation. All I'm going to do is move the 2x over here and the 3y over here. But when I do that, that 2x is positive and my 3y is negative, so make sure the signs stay with the appropriate term. The reason I wanted to show you this one was not just to rearrange it, it's because anytime you've got the same coefficient, my x's are the same. If you have the same coefficient, they have to be opposite. So if they're both 2, if they were opposite, one would have to be 2, the other one would have to be -2. So you can go through and you can multiply any equation by any value as long as you get opposite coefficients. So what can I multiply by 2 to make it -2? I need some help.
-1.
Perfect. So if I multiply the entire equation by -1, I've got 2x plus 5y equals 4. Distribute this to everything. -2x plus 3y equals 12. And once you have opposites, again, you just add them up. So I've got 8y equals 16. Divide by 8, and y is 2. Any questions so far? Again, I know it's been a long time since you've done this. So we're started with a couple easy examples. It's going to get more difficult. So once I have the value for one of them, how do I find the value for the next? Just plug it in anywhere you want to. So I think up here it's all positive. I'm going to plug it in right here. So I have 2x plus 5 times 2 equals 4. 2x, 5 times 2 is 10, equals 4. Subtract 10. Divide by 2, and x is -3. So where do these two lines intersect? At the point -3, 2. Now right now I'm largely just running you through this, but I do need a little participation here. If we were in class, I'd come through and you guys literally would talk every single day. I say in class, I meant live in person, you know what I mean. But that's it. Now, any questions at all?
Wasn't there like, I feel like when we were learning this, there was like names for the different ways to solve it. It was like elimination or something?
Yeah, and this is called solving by elimination. And I'm not even going to talk about solving by substitution, at least not right now. So there's elimination, there's substitution, there's graphing. There's several different ways.
And I'm assuming it's all just a way to find how they intersect.
Exactly. By the way, this is not going to help you when we do the Algebra 2 stuff, but if you ever got to a test or a quiz and you had a 2x2, and you can't do it with a 3x3, but a 2x2, you could always just solve for y and type this in your calculator and find the point of intersection. I'll show you that another time, but remember, I'm just trying to find where these two lines intersect. That's it. And I'm telling you, doing it by hand is probably going to be actually quicker than doing it in the calculator. Let's look at problem number 3. Again, I'm specifically teaching you elimination because that's how you have to do it tomorrow in the 3x3s. The first question I'm going to ask you tomorrow is the same thing that I'm going to ask you today. which variable do you think is easier to cancel out, the x's or the y's? And why do you think that's easier to cancel out? I need somebody to help me out here.
The Y.
Why'd you say the y's?
Because it doesn't have a number. Well, for the second equation, it doesn't have a number. Well,
Perfect.
even though it's 1, but yeah.
Yeah, that's exactly right, Jasmine. So you guys make this easier on you. There's no wrong answer, but there's a better answer. So what that means is if I ever see I just have a positive 1y, all I know is I only have to make one multiplication here. So the work's going to be even easier. I want the opposite of positive 2, so I'm going to multiply the entire equation by -2. When I do that, here's what I've got. Now make sure I distribute it to everything. That's the most common mistake. By the way, when we do this with 3x3s tomorrow, it's not difficult, but the biggest mistake is going to be signs. You missed a sign somewhere. So make sure that you keep your work nice and neat. Once I have opposites, now I add I combine my like terms, I add them. So 3x plus -4x is -1x equals -1. Remember, this has to be positive 1, so when I divide by -1, x is 1. Now, how do I find my solution? By plugging it in anywhere up here, and it doesn't even matter. I'll plug it in right here. 2 times 1, which I don't really need to do, I'm just showing you. 2 times 1 is 2. So my entire answer is the point 1, -1. Questions there?
Wait, what did you just do right there?
So what I did, let me change colors here. So did you understand how I got this one?
Yeah, I understand that. I was just trying to figure out what you were doing.
Yeah, once I've got this one, all I have to do is plug it in for x, and I either have to plug it in right here or right here. I don't have to do it to both of them.
Oh, okay. You just plugged it in.
Yeah, you just plug it in and then you solve for the other one. So I'll do it up here just for good measure so you guys can see. 3 times 1 is just 3. But I'll go ahead and write that equals 1. 3 times 1 is 3. So if I subtract 3 from both sides, I have 2y equals -2 and divide, and I still get -1. So it doesn't matter which equation you plug it back into. Okay? Any other questions? Okay. Now, we're running out of problems. I say out of problems. We've got 1, 2, 3, and I think that's it. Yeah, we've got 3 left. So these last 3, make sure that you guys are following. Again, I'm working under the assumption that unless you have questions, that you guys are getting this. So the whole thought here is I want to eliminate the variable and doing as little work as possible. And I think you guys can agree with that. We want to do as little work as possible and still get the right answer. So which one is easiest to cancel out, the x's or the y's?
X's.
Good, Landon. So again, there's no wrong answer, but I see that I've got 6x and 3x. So I want to do as little work as possible to get opposite coefficients. Well, what can I multiply by 3? The opposite of 6 is -6. What can I multiply by 3 to get -6?
-2.
Perfect. So when I do that, the top equation hadn't changed. Bottom
I'm confused. Why you got to divide it? I mean, multiply by -2?
Because so you guys chose to eliminate the x's, which is a good choice. So I need a set of opposite coefficients. So if this is +6, the opposite of +6 is -6. So what can I multiply by 3 to get -6? And the answer is -2.
Oh, okay. Thank you.
You're welcome. Does that make sense?
Yeah,
So
thank you.
Okay. It is all about getting opposite, and then it has to go to everything. opposite coefficients. Now again, we are only using today because nothing about this is an Algebra 2 standard. We are only using this today to make sure that you understand everything about it before we get into tomorrow. So once I have opposites, when I add these two equations, these will cancel out. So negative 5y plus negative 4y is negative 9y, and 2 plus negative 20 is negative 18. Divide, and y is 2. Again, I'm going to stop right there. Now, if somebody wanted to cancel out the y's, that's perfectly fine. In fact, I might even put up another example. That is not a bad choice. But the x's were better because I only had to make one multiplication. Once I have one variable, how do I solve for the other?
You plug it in.
Plug it into either equation, doesn't matter at all. So if I plug it into, just because these are all positive, I don't want to make any silly mistakes, I'm going to plug it in right here. 3x plus 2 times 2 equals 10. So I'm literally just taking this value and I'm plugging it in for y. 2 times 2 is 4. Subtract 4. Divide by 3. And that's my solution. By the way, some of the small work, if you need to see the steps, I don't show or walk you through every single one. I can. So make sure you ask questions. But sometimes when we can save time and go quick, I'd like to do that. Any questions? No? Okay. Now, we're starting to get to the nitty-gritty finally. This is going to happen all the time tomorrow. There is no wrong answer here. I'm not even sure there's a better answer. So we might actually put another one up here just to show this again. So we've only got 2 more sample problems. I might put another 1 or 2 up here. So I want somebody to tell me just which one would you prefer to cancel out? And it's just a preference, the x's or the y's. Again, no wrong answer.
X's.
Okay, so I heard the x's. If you are having any doubts about this at all, somebody said the x's, which are fine. So if I'm trying to cancel out the x's, I'm going to have to multiply both of these equations. Please watch at how simple this can be. So I chose the x's. You see how the top has a 3 and the bottom has a 2? If I'm trying to get a just opposites, the 2 is going to go to the top and the 3 to the bottom. And then let's think about this real quick. That would give me 6x minus 4y equals negative 22, and that's also 6x, but I don't want them to be the same. I want them to be what?
Opposite.
So one of them has to be negative 6. So one of these, and again, it does not matter which one of them has to be negative. So I'm going to go ahead and make the top one negative. Any questions? So when I distribute, the top one is going to be this. Remember, that goes to everything. That's another common mistake. The bottom one is.
Wait, so why did you have to switch it again?
I didn't necessarily switch it. That's not how I want you guys to think of it. But what I did do was I'm trying to make this as easy as possible. So if I see that this is a 3 and that's a 2, then the top one gets a 2, the bottom one gets a 3. And I'm multiplying. So basically, if I had this, 8x, yada, 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 and this was 5x, yada, 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 and I want these to be opposites, the top gets a 5, the bottom gets an 8, because 5 times 8 is 40, and 8 times 5 is 40. Does that make sense?
Oh, you're multiple. Okay.
Yeah, you're just multiplying.
Okay, I got confused.
And then one of them has to be negative, right? So
Oh,
I want opposites, not the same, but opposites.
okay.
Okay.
Wait, so when you find what y is, do you plug that into the 3x, or would you plug
You
it
can
into?
plug it into absolutely anything. That's a good question. So right here, once I have opposites, add them up. Negative 17y equals 34. Divide by negative 17, y is negative 2. So this is exactly what Caden was just asking about. All of these equations are equal. It doesn't matter. So whichever one of these you think would be the easiest to plug it into, could be either one of these two or either one of these two. It doesn't matter. So that just gave us more options. So I'm going to go ahead and I'm going to plug it into what I think is the easiest, which is the bottom one right here. So again, if y is negative 2, I plug it in. Negative 7 times negative 2 is positive 14. Subtract 14. Write your answer as an ordered pair. There you go. This is the type of problem that you really need to have down. Any questions? So let's look at this, and if we need to see another example, I will give you another example. Again, there's no right answer, no wrong answer. But which variable do you want to cancel out? It does not matter to me at all. The x's or the y's, either way. So I need somebody to answer.
Cancel the Y's.
Okay, so they said the y's, which are perfectly fine. Again, I would have been perfectly happy if they said the x's. That was a personal choice. They chose the y's. Hey, Jasmine, why did you choose the y's?
I don't know. It just looks a little simpler, I guess.
Okay, and that's fine. Some people will go through and say, well, because they're already opposites, one's positive, one's negative, and that's fine. So now you know that the signs are correct, but now you got to get the right number, right? So again, I want you guys to see this. We chose the y, so kind of watch how I'm doing this. This is setting us up for tomorrow. I chose the y's. You have a 3 on top, so you need a 3 on the bottom. You have a 5 on the bottom, so you need a 5 on the top. Now, when I multiply this out, make sure that those end up being opposites. So multiply it out. Distribute this out. And they were opposite. So again, 5 times negative 3 is negative 15, and 3 times 5 is positive 15. So when I add them together, oh boy, 37x equals, oh man, that's going to be really tough, isn't it? Oh, that was negative 50. See, I made a mistake. 95% of the mistakes made on this are sign mistakes. Divide by 37. Any questions about that? Now to solve for x, plug it into any one of these equations. I'll plug it into the bottom. Add 8 to both sides. So I got 5y. Sorry, that's a 5y. When I add 8 plus negative 8, I got 0. Divide by 5, and y is 0. So you've got the point, negative 2, 0. By the way, one thing that I haven't addressed that I know they talk like crazy about in Algebra 1 and pre-algebra was checking your answer. If you are ever unsure, if that doesn't look right, if something's messed up, or you just want to check, All you have to do to check your answer are plug these points back in and make sure they work for both equations. So -2, 0. If I plug -2 in for x in the top, 5 times -2 is -10. I plug 0 in for the y, I get -0 plus 0 equals -10. Will work for the top. Try the bottom. X is -2. 4 times -2 is -8 plus 0 equals -8, and it worked. So you can check your solution by plugging that into all of your equations. Does anybody have any questions? All right, I'm going to give you one more example, actually. I was going to let you go. I want to give you one more example. I'm going to make a really messy, equation here. And I'm going to show you what happens if it gets really messy. So let's do something like this. 3x plus 5y equals 2. And let's do like 4x minus 3y equals 5. So I'm pretty sure this is going to be ugly. I want you guys to follow. I'll make this bigger. I want you guys to follow, because what do you do when something gets really ugly? Let's just kind of start over with what you know. All right, so hold on. I'm going to pick the x's to cancel out. So if that's the case, and I've got 3 and 4, and I need them to be opposites, this would get the 4, and that'd be the 3, but one of them has to be negative. It does not matter which one. So I've got 12x plus 20y equals 8. Down here at the bottom, negative 12x plus 9y equals negative 15. Those will cancel, so I've got 29y equals negative 7. So y is negative 7 over 29. Now, I did this on purpose, so please watch. Now, on your homework, on any assessment, it's not going to be this ugly. But I have seen something like this on the SAT and the ACT. So if that's the case, now you could always plug it back in, but you're going to have to deal with fractions several times if that's what you do. Instead, is everybody watching? Make sure you watch this. This is the last thing I'm doing. Instead of plugging this back in, you know what I could do? I can come back up here, and this time I could just cancel my y's. So I could do the same type of problem twice. Now I want to cancel out my y's. So the signs are already opposite, but the top needs a 3, the bottom needs a 5. So anytime that these problems get too ugly, you've got a number that you don't want to plug back in, you can just cancel out the other variable. And watch what's going to end up happening. What do you notice about the denominators? They are the same, and they should be the same. All right? So if you ever get an ugly fraction that you don't want to plug back in because you have to work with fractions, that's fine. Cancel out the other variable. Now, you guys do have a big ideas assignment tonight. It should not take you too long. It's all 2x2 equations, 2x2 systems, just like that. It is due at 11:59 p.m. tomorrow. Real quick, let me take attendance before you guys go. Is Jackson on here? Jackson, if you're on here, unmute yourself and say hi. See, Latavia's on here. Lizbeth, are you on here? Yes. What about Soraya Payne? No. All right. What about Mikkel? What about Darius? No. All right.